LeetCode coding challenge, and today we are going to solve our next problem statement, odd even linked list. So let's start. Given the head of a single linked list, group all the node with odd indices together followed by the node with even indices and return the reordered list. The first node is considered odd and the second node is even and so on. Note that the relative order inside both the even and odd group should remain as it was in the input. You must solve the problem in O1 extra space complexity and On time complexity. We have given a linked list and 2, 3, 4 and 5. And if numbering start from 1, so this is first index, this is second, this is third, fourth and this is fifth index. So we need to put odd indexed node first and then put the even indexed node second. What we going to do? Put the odd indexed node first. 1, 3 and 5 indexed node comes first and then put the even node. So 2 and 4. For this problem statement, do not get confused by the value of the node. We need to put the odd number indexed node first and then the even indexes node. It doesn't depend on the value of the node. So for the second test case, the first value itself can be even, but this node is at the odd position. So 2, 1, 3, 5, 6, 4 and 7. You can start numbering from 1, 2, 3, 4, 5, 6, 7. This is our indexing. Now put the odd indexing first. So 1, 3, 5 and 7 indexing comes first. So 2 and 3 and 6 and 7 comes first. Then put the even indexing 2, 4 and 6. 1, 5 and 4. So this is the answer. Now let's come to the solution part. How can we solve this problem statement? Suppose this is our linked list where we have given a head pointer and linked list contain the odd node and the even node. Our even node we have marked it as a red color and our odd node is marked as a black color. So we can define our two head. One is the odd head and second is an even head. So odd head is the first odd node. It is pointing to the first odd node and even head is pointing to the first even node. So first node is always the odd one. So we have added the head, initialized it with the head, and second node is always even. So that's why we have initialized it with head.next. Now we have defined two more variable, odd current and even current, which will always point to the current value of the odd node. So we initialize the odd current and even current. It is pointing to the first odd node and the first even node. Then what we can do, we can keep breaking the connection between the odd and the even node. So for this odd and the even node, we break the connection between them. Similarly, the second connection also we break, and our odd node we point it to the second odd node, and so on. Similarly, for even node also we do the same thing. So the even node now will point to the even node. What we are doing in this activity, basically all odd node should point to the all odd node. First odd node should point to the second odd node and then second odd node should point to the third odd node. Similarly, we are doing for the even node also. First even node pointing to the second even node, then to the third even node. So our final result will look like this. We have done this and all odd node in the one place and all even node in one place. Now odd node we can travel through odd head that we have initialized at the starting, and even head node we can travel through the even head. In the first activity, we also need to keep keep deleting the connection between the odd and even node, and we should also build the connection between the first odd node and the second odd node. This same activity we also need to do for the even node. When our odd node linked list is built and our even head node linked list is also built, we can simply merge these both lists, and we can point our last odd node to the first head node of even. So now we have built our final linked list. And for this approach, we are not using any extra space. We will only use a new variable that we are going to define. And on the existing linked list only, we will keep breaking the connection and and try to form a new connection between the odd node and the even node. So let's do the coding part and try to do this implementation that I have shown to you. So first, we are defining these two variables, odd head and even head, and also our odd current and even current variable. List node head of odd. Let's delete this part. Odd head, it will point to the first odd node, and even head, it will point to the first even node. Now, odd node is going from first to third position, and even node is going from second to fourth position. But for every iteration, we are moving both odd and even node. So even node will always be ahead of the odd node. So we need to do the while loop. We need to come out of the while loop as soon as our even head node comes to the null. But we also need to define these two variables also, odd current and even current. These odd current and even current variable will be our temporary variable that we will going to use to iterate over our linked list. Because if we iterate over our odd head or even head, we will lose the pointer to the first odd node and even node. So we need to define temp variable odd current, which is pointing to the first odd head only, and even current value, which is pointing to the even head. We stop the iteration on the linked list as soon as our even current value comes to null. So iterate only when even current is not equal to null, because our even current will always stay ahead of our odd current. The even current is equal to null. Now we need to make a connection. So the odd current will point to the even dot next. So next node of even, odd will point to the next odd node. So odd dot next, it will point to the next odd node. So next of even, next node of even is the odd. So now our first odd node is pointing to the next even node. We need to use a temporary variable. Now we also need to move our odd node also. We have now first odd node is pointing to the third odd node, but we need to move it also from first to third position. So odd current, move your odd node to the next node. Now we also need to move the even node also. So now our odd node is now moved to the next odd node, and now the next odd node is pointing to the next even node. So our even current node now our next node of odd is even, and now our even node is pointing to the next even node, and then we move our even node also. One more thing, there is a edge case where might for if the number of node is odd or even. There might be a case when the odd current can go null. It can comes at last. So we need to check that condition also. So if at end, if our odd current goes to null, if it is not equal to null, we attach the next element. If it goes to null, we return null. Now this is done. Now we reach to this part where we have all the odd node and the even node separately, and we have this odd head and even head. Now we can just move the odd head to last, and then the last odd head will point to the last odd node will point to the first even head. To move your odd head to forward, so while odd head is not equal to null, move your odd head to next position. So now it has reached to the last position. Now we point the last odd node to the first even node. The first even node is even head. So even head. Now this is done. At last we return our head node. So we have not used any extra spaces. We have defined 4 variables, and through it we have done all the computation of separating the odd node and the even node, and then merging the odd node and then the even node. So now let's run the test case and see if it is working. So our test case is working. Now let's submit the solution. Yeah, there is one case where we expect that at least we have 2 nodes in the linked list, but there can be a case where the our linked list is empty or it have only 1 node. So we need to handle those cases also. If the list is empty, we need to return the empty list. If the list have only 1 node, we do not need to do any operation. Then also we need to return the head node. So if our head is equal to null, or our head only have 1 element, we return the head itself. Now let's submit the solution. So our solution is also working, and thanks for joining the session. Let's meet tomorrow.